Okay, in this video, I'm gonna talk about this diagram of chapter 1 as this figure 1.1, the program development process. Now, if this is your first time programming, it's really important that you understand this diagram. Let me zoom out just a little bit so we can see the whole diagram. A little bit hard here, but okay, maybe this will do. Right, so this is similar to what's called a software development life cycle, or SDLC. If you are familiar with this term, then this is the process of how writing a program and from beginning to end. Okay, but this diagram here is a very general purpose diagram that would apply to pretty much all programming methods. So when you write a program, the first thing that you need to do is you need to come with a project, right, or program logic. Basically, what that is a problem to solve, and that's what we write computer programs to do, to solve a problem. So a problem would be like, for example, to calculate your taxes, right, or to calculate a sales purchase or something like that. So a typical problem could be maybe like to calculate the student average grade of a series of exams and things like that. So once we have that a plan or the program logic in mind, then the first thing you need to do is to put these things together. Gather the data. What type of data do you need? And then what are the variables you need to put together, the calculation, the formulas you need, and then finally you want to output this whole thing to a screen, or print it out or something like that, right? So that's what you need to do. So let's just say, in our example, we're gonna write a little program to calculate the student average grade, right? So once you do that, and this is what happens here in the first box here. This first box here, that's what you do. And right before you go into the second box, which is to write your program language statements, you would normally write something called a pseudocode. Okay, so a pseudocoding. A pseudocode is just another fancy word for writing. You try to write the actual code, but not the real code yet. So that's why the word pseudo, right? Pseudo means like not real. But your code would your statements, or the way you write your code, would kind of mimic the actual code. And most of the codes are mainly just like really simple English sentences or phrases that would show you the step by step process of how to solve a problem. Okay, and there are no universal standards for pseudocode. You can write as few as you want, as many lines as you want. It doesn't matter. So for example, let's say our problem here is to calculate the average grades of a student's test. And so I'm going to go to Eclipse here. Okay, this is the Hello World example. I'm going to add another project here. Okay, you can have as many projects as you want here in this window. Actually, as you start to build your classes, you're going to have a lot of projects here. And so now I'm going to add a new project. So I'm going to call this, I'll just say, student grade average. Okay, I'll keep all these as default and just click finish. So I have my second project, and I'm going to close this one now. My second project, then I need to add a class. You can do a right click and then add new class, or you can also click the shortcut here, this green icon here. This is the class as well. So new class, and then I'm going to add again maybe student grade average. It doesn't have to be the same as your project, by the way. It could be anything, but this will be the exact name of your Java file. So make sure it matches exactly here. But in the IDE, Eclipse, and if you're using NetBeans, these will be generated automatically for you, so you don't have to do that. But if you were to do this like using Notepad or some type of simple editor, then when you save it, you have to save it with the exact same name. Okay. I'm going to add a public static main because this is the only program. Then click finish. Okay, so here in the code, if this is too small, I'm going to make it a little bit bigger so we can see. And you can change the font size here by going to Window, Preferences, and I think under the General Appearance, Color. It's kind of take a long way to get there, but I think it's under the Text. Yeah, Text and Font. And I'm going to edit that. And I'm going to change it to a different font size, maybe 14. Yeah, that should be big enough. Okay, a little bit bigger. For now, I don't need this over here, so I'm going to just close these out so I have more room. Okay, so here is again the typical Java program. This is a comment, right? It's a single line comment with the double slashes. If you want to comment more than one line, so you want to use the /* and then put your comments in here, right? And then you can close it like that, and you can have as many lines as you want. Okay, so this is a comment. So to use comments to comment your code, because it uses to not only just to help you remember your code or remember what's going on in the program, but also helps other programmers as well. When they come and look at your code, they will know what's going on. Okay, so it's very common to use that, and I will highly encourage you to, document your code. So I'm going to delete this one here. I don't need this one for now. So let's say I want to do the pseudocode. If I put 2 dots there, 2 asterisks, you'll see that it generates this for me automatically. Okay, which is nice. So I don't have to close this manually by myself. Okay, this is another way of to document your code. This is called the Java doc, and when you use this syntax, this way of documentation, then you can actually put HTML tags in here, and you can use this. And then when you render this, actually you have a Java doc command that can actually translate everything here to a web page. So I'm not gonna do that now, but so the pseudocode. So this is a pseudocode. I'll put that here. Okay, so we want to let's just say oh, another thing, I want you to do this as well for every program that you write. At the very top here, I want you to include the following. Okay, your name. All right, so you can put your name, the project title. So on this one will be like student grade average, the title of your project, and then a description of that project, what this program is going to do. So you can say calculate student grade average. And you can be as detailed as you want, or basically you want to just put a sentence or two, depending on the complexity of the program, to tell us or to tell other people or programmers to so they'll know what's going on in the program. And then finally put in the date. Okay, so this is, for example, May 2017. And so you keep a record of your code. Usually you can always update this as you change your file. So always do that at the very top of your program, so I'll know. And you can always just copy and paste this later on. Okay, so in the pseudocode area, we want to do the following. We want to, need to know the total grades. So we have so we say set total to 0. That'll be a pseudocode. You also need maybe a count, an average, right? Set average to 0. This is when you initialize your program. And you also want to have a counter. You want to know how many grades there are. So let's just say you have 3 exams or 10 exams, and you take the average out of those tests, right? So you have a counter. And in this example, I'm going to set it to 3. Okay, set counter to 3, so we have 3 tests. And then what else? Then once you have those, you need to read some data from the user, right? Or from a file or a data entry somewhere. So I want to say a read input into grade 1, okay? Read input for grade 2, and one more for grade 3. So you have 3 grades, and we'll take the average out of that, right? So once you read those grades, then you can go and calculate the total by saying something like total is equal to, grade 1 plus grade 2 plus grade 3, right? You get a total, and then you can find the average by setting average is equal to total divided by your counter, which is 3. Okay, and then finally, when you're done with this, you can say, let me turn on this counter console here. You're going to print the average to the screen. Okay, so this is an example of a pseudocode. All right, so this kind of gives you a step-by-step process of how to actually code your program. And if you follow the pseudocode, you can actually easily translate this into a program. All right, so that's let's go back here. That's the first step here. You have your program logic. You have written in pseudocode, or some people will use flowchart. That's fine too, if you're familiar with flowchart. And then the next thing is to translate the pseudocode into the actual program language. Okay, and then we'll once you have that written out, it will compile it. This is the compilation here. Compile your code, and it will check for any syntax errors. If there are any errors, and we go back and fix it. And there's no error, then the program will execute, and then we'll see the output. Look at the output here, and then I would see if the output is good or not, right? If there are any errors, we have the runtime or the output errors. If there are no errors, then we are done. If there are errors, then we have to go back and fix it again. Okay, so let's go into the second box here to write the program. So now we're going to translate this into actual code. And I know we haven't covered the variables yet, which will be covered in chapter 2. But following the pseudocode, this is how you would set your variables for. So we have total, average, and counter. All these are, if you look at these numbers, now on a hypothetical test or exams, normally your grades will be in, you might have like decimal numbers or things like that, right? And it's not going to be just a whole number. Maybe you might get a 95.3 or something like that, right? So those will be in the terms of data type. If you look at chapter 2, you have different types of data. You have the integer. As you know, integer takes only the whole number, right? There's no decimal values. So that would not be a good type of data for the total or the average. The counter can be an integer because counter is just a count, right? It's a whole number. But the total and the average will be something what we call a double. Okay, a double is a decimal number that has a certain maximum range of numbers. Okay, and then another one is called a decimal type. A decimal is much larger than double. So typically we'll set this to a double type. And the way to do that is you would type the data type first. So it's going to be a double, and then followed by the name of that variable. And in this case, it's called total. Okay. And you terminate that statement with a semicolon. And the second variable is average. So both of these will be double data type. In other words, you can put a comment here. Okay. So total could be something like, maybe you have 98.9 for your grade, right? And same thing with the average. Maybe your average could be like 95.456 or something. Okay, so I had decimal values. The next thing is the counter. So the counter is just a counter, so we're going to be an integer type. So it's just int counter. And I'm going to now, so the next 3 variables are your grades. So again, these will be kind of the same thing with the with the double and then a double data type. So we have double grade 1, double grade 2, double grade 3. Okay, notice if they're all the same data type, I could do it this way, or I could do this way, grade 1, comma, grade 2, comma, grade 3. Okay, but okay, that means that I already have these here. I can't have it twice, right? So if I do to delete this, you see that I can use that as well, which is fine. And sometimes you'll be doing that because it's much shorter, right? Okay, so I'm gonna put it back here the way it was before. Okay, so these are your local variables. You can comment these as local variables. You can be more specific to what they are, what they do. Okay, and this could be like maybe a student, grades, right? Or test grades, right? Maybe something like that, or test scores. Whatever you want to call it, that's fine. Now the next thing is we want to set the values to these. So this will be your initialization. So you want to set the total to 0. Okay. Also set the average to 0 because right now there's no values yet. We haven't done any calculation. Then the counter will also be 0. Okay, so that's the set. The next thing is you're going to read the input from the user. So normally you would do an input, you would prompt for a user to enter some data, but we're not going to do that here. I'm just going to assume that the following takes place. So this is for reading the input. I'm assuming that I would do a command to prompt the user to enter data, and then a grade 1 will receive a value of, let's just say 98.5 for the test score. Okay, and then grade 2 receives maybe a 95, and then grade 3 receives an 88.74 or something like that. Okay, so I got the reading the input. What's the next step? We're going to calculate the total and the average, and then finally print out the average. Okay, so this is calculate total and average. So the total, let me do this. Let me just put some lines down here so we have some spaces in the top. So the total is going to be just simply again grade 1 plus grade 2 plus grade 3, right? And then the average is total divided by your counter, because we have only 3, right? The average is you add them all divided by the number of the quantity. So if you look at these two lines, 54 and 55 here, okay, they look very similar to your pseudocode, right? And that's why pseudocode will kind of mimic the actual code itself. So the closer you get to the actual code, the easier it is to translate to the actual code. So finally, once we get that done, we're going to print to screen. And print to screen is system.out.print line. And I'm not going to put a string here. I'm going to print the average. So I'll just put the average variable right inside here. And then I think that's it. Okay, so I'm going to save this. Control S to save. And let's run this program. Okay, so I compile it, and I get an infinity here. And we'll see what that means. Okay, so, but anyway, so you see that we did the program. We calculate here. We compile it. We run the statements, and then we see that there is no syntax errors, right? This is not a syntax error. If there is, it would crash and it would not run. So, sorry, that was a phone call. But anyway, so we executed the program. It runs. There's no syntax error. Executes the program, and it so we examine the output, and the output says we have a something called infinity, right? So if you remember, the output, it says infinity, and instead of infinity, you should supposed to get a number, the average of these three numbers here, right? Something in the neighborhood of 90 something, right? So we'll get to that in a minute here. So back to this again. And we examine the output. Are there any runtime errors or output errors? Yes, we have some type of errors, right? If there's no, we get the expected value, then it will be no, and we're done. But now we found that we have some error, and then we need to go back and fix the problem, okay? And the example we have is infinity. What this is if you look at this diagram, it will be something called a output errors, but really it isn't a runtime error. You know, I will show you why. But just so if you look at this diagram here, I mean this code here. So what's infinity? So the average here is total divided by counter, right? And if you look at this, there's no syntax error. A syntax error will be like if you mistakenly mistyped total or grade, or you forgot to put a semicolon here. For example, if I take out the semicolon here, and the IDE will tell you right away that you are missing something here. But let's assume that you don't use this IDE, and if you use a simple like text editor such as Notepad or Notepad++, it doesn't tell you the syntax error. And of course, this is a simple program, but you might have a program that runs in the neighborhood of hundreds or thousands of lines of code. You probably might run into some type of syntax error. And let's just say if I have this example and I save it and run this file, then it will tell me I have an error. If I proceed, it tells me that I have an error. I have a compilation error. It's called a syntax error, and it gives me two options. I either insert a colon. This is something we're not going to do here for now. But typically you have a semicolon error to complete a statement where it's in this program, student average, that's this one here, dot main, this is the function main, so this is in the main method, okay, at line 54. So if you look at line 54, you'll see that this is what the error is, and it asks you to insert a semicolon. So this is an example of a syntax error. If you forgot, if you miss something, and if you violate the the syntax rules, then you have a syntax error. Okay. So now back to where it was. So if I run this again now, if I fix it, if I run it, I don't have a syntax error, but I get something called infinity, which is a wrong output. Well, what that does is something's wrong with my average. So if I look at this, my total looks good. Counter, if you look at counter, you'll see that counter has a value of 0. So this is really a division of 0, right? Division by 0. And usually this is not legal in mathematical operations. But for some reason in Eclipse, it gives me an infinity. Okay? And let me switch over to NetBeans. So here in NetBeans, this is the simple Hello World program. If I run this, you'll see that it prints out Hello World. Okay, if I were to do the same operation there, if I say give me the operation of, let's just say 10 divided by 2, right? That should give me 5. Okay, so I have 5. Now if I put a 0 here, 10 divided by 0, it violates that division by 0 rule in math, and that's going to give you an error in the NetBeans IDE. It says exception is an error, okay? It's called a runtime error, and it's a division by 0 rule. So you have to fix it at line 20. So here's line 20, and I have that error here. So NetBeans will give you this error, whereas in Eclipse, it gives you infinity. And the reason why it doesn't do this here is because I think according to the IEEE consortium, they figure that any number divided by 0 will give you an infinity, and I think that's why Eclipse will embrace this issue here. So normally if you divide a 0 here, and Eclipse, it will not give you any problem. You would see an infinity here. Okay, so if you want to check for this division by 0, you have to manually check it yourself. Okay, so this is an example of what's called a would be an example of a runtime error. Okay, so if you will see here, it's a runtime error. Okay, runtime errors are things like let's say you have something that is not assigned to, it's empty, then you have a runtime error. Or if you have something is out of the index, especially an array. Let's say you have an array of certain values, then you will have an issue with that as well. For example, I can just show you really quick here. We will deal with arrays later on, but let's just say I have an array. Okay, an array of an array is just a structural variable that contains elements of data. So if I put int, array uses the curly square brackets of numbers, num is equal to 1, 2, 3. Okay, that's an array that contains 3 elements. And array, you would access or get the numbers by using the index numbers or index value. So in the first position is the 0 index, the second is the first and second, and so on. So it's always one less than the actual number there. And if I want to print out the number 1, I would do it this way. I would say num, that's the variable name here, and I would use the square brackets to specify the index position, which is 0. Okay, so that will give me the number 1. So the number 2 in there will be the index 1. Okay, so that gave me 2, and then num3 gives me 3. Okay, we'll do this later on, but I just want to show you what another example of a runtime error. Okay, so I have that, and then now I want to print out to the system, to the output. Okay, print len num. So if I want to print out the first number, which is 1, the output 0 here. And let me comment this out, so we don't print the infinity. I'm going to print the array down here. Okay, so I'm going to save this, Control S to save and run. Okay, you'll see that the value is 1 because it's 1 here. Maybe if I do this, 10, 20, and 30, that's better. Okay, so again, run, compile, 10 because that's the first position, which is referenced by 0. If I want to print the second number, I just replace it with a 1. If I run, I get 20, and the third number is 30. Okay, if we put a 3 there, I get an error, right? It's called the index is out of bounds exception error, and there's no such thing as index 3. Well, if you look at the code, I don't have any errors here, right? It looks clean, looks good, no red squiggly lines here anywhere at all, nothing here. It looks fine. But when you compile, you run it, it says there's no such thing as index 3 because I only have up to 2. Okay, so that one goes here, that goes there. So this is an example of a runtime error, an out-of-bound index error. And there are many others, but this is a common one. Another one is if you were to, remember I said that you have to have the same file name as your class name. If you have a different name, even you don't match the case here, it's going to generate an error as well. So there's another error here. Okay, so that is the error for a runtime. The other part is this output errors. What's an output error? The output error is called a logical error. This is probably one of the most difficult errors, and it can become a nightmare for most programmers. A logical error is if you have a program that runs, but you don't have there's no syntax errors, no runtime errors. The output just doesn't what you expect. Okay, so I'm going to change the counter back to 3. It should be 3. So now if I run this program, it's going to output the average of these 3 numbers and correctly. Okay, so it's 94.08, that's the average. Right? So let's just say if I were to put, I accidentally, let's just say put total here instead. Right? Not total. Maybe we'll put a different number. Well, let's just we have maybe I put like total is not good. Let's just say I have another integer here. Int. Let me kind of follow my rule here. So I have int counter, maybe counter 2, right? And then counter 2 is 2. Okay, well, let's just say you're supposed to get the total of these three numbers, but you accidentally put counter 2. Okay, so if you put counter 2, and if you run this code, you see you have a different average, right? There's no error in your code. Nothing here, no errors, no debug. I mean, no syntax, no runtime errors. Everything looks good. But when you run it, the output is completely different what now we expect. Okay, because you mistakenly accidentally used the wrong variable names in here. So you might use this as in a different location, a different place, and a different context. So this is out of context here, but it doesn't give you any errors. So this is one of those examples that is really hard to trace and find the location of that error. And this example is really tiny, so it's easy to catch. But imagine you have a really big program, and let's say it's a text program, and finally when you print it out, the result you have a negative result every time. Now what do you do, right? How do you fix that? And so you can see you have to trace your code for everything from top to bottom, line by line, sometimes, to find out what the error is. And so when you do that, you actually put a flag somewhere in your code to make sure that to kind of trap what that error is. And IDEs nowadays have some tools to help you, some debugging tools to help you resolve those issues, but it still sometimes is very difficult. Okay, so this is an example of a logical error. So you have three types. You have the syntax error, if I don't do that, or if I mistype with the 4 instead of 3. Syntax error. Okay, you have the logical error if you divide it by 0, right? And then you have the logical error. You have unexpected result. Okay, so this is the diagram used to kind of help you, guide you to write your code. And this is it's a very common process for all programs. When you start running your code, it's going to go through this whole process. And most of your times will be spent on coding here and debugging, okay? Because the output may not be correct, or you have syntax errors or all those issues. Okay, so I hope this is helpful. And if you have any questions, again, please post in the forum or send me an email. But it's important that you understand this logic here. If you understand this, then this applies to all programs.